Okay, guys. Assalamualaikum and good afternoon. So we are doing a hybrid class. Hybrid means more than one options. Face-to-face like today and online as well to give chance to our friends, our remaining friends that not able to come. Okay, understand? Okay, so I have to sit because some of your friends is on the right hand side in the virtual world. Okay, it's not reality world. All right. So for 1 hour class today, I will sit because I cannot move around. So I use my iPad as the whiteboard. See, the quality of our whiteboard after 2 years left is quite terrible. Okay, so I need to make a complaint to clean up this whiteboard so that easy to write. So for test 1, which is held on the 27th of April last month, I have marked almost 50% of the students, and the results is not really convincing. Okay, majority still below passing mark, which is 7/15. So without any further ado, I will discuss what actually the truth answer of the test 1. Okay, so I invite our sister Liana Camilia. Can you read the questions for me? As usual, it's a two-way communication in the class. Where is Liana? Liana Camilia? Ah, yeah. Sit down. Can you read? Can you read? Shh, everybody quiet, please. Continue. Okay. So what do you understand from the given figure? Figure 1. We have a system A and system B. This one is okay. Ini apa ni? Is a complex conjugate zeros. Am I right? And this one is complex conjugate poles. Okay. You can write if you want, but if you missed, I will share the link. It's recorded. Okay, so please keep quiet because your noise will come to my iMac. And then from the theory, I said that the rule locus started from poles and ended at zeros. So, okay. And we have over here is a breakaway point. Am I right? Okay. And this one starts from the poles and then enter to the zeros. Okay. And this one is a break in point. Okay. And what is this? Apa itu? Ada J omega axis. Is a KC. Okay, where the gain, critical gain happen. Quiet please. K critical. Okay. And what is the value at this zero? K infinity. This one also K infinity. And what happened to the K at the poles? K zeros, K zeros. On the other side of the system B is K equal to 0, K equal to 0, and this one is K equal to infinity and K equal to infinity. Okay. Go ahead, please. So based on the S-plane on the whiteboard and on the iPad, okay, it's too crowded. That's why I moved to the whiteboard. So you can see that the difference of stability status based on the figure A and B. Okay. So what you should discuss here, we have a okay. So you build a table, okay, and then you discuss. So better you create a table. So this one is A, this one is B. Okay. K variation of K. So the K start from 0, 1, 2, 3, 4, 5, 6, 7 till infinity. So I mark here at the zeros, K towards infinity, and the poles here, K equal to 0, K equal to 0. But when the intersections between the root locus and the imaginary axis will produce K critical. Okay, so that is the difference between the stable and unstable. That is the borderline. Okay, that is the borderline here. So this one is, we call it as a unstable region. Okay, unstable. And this one is stable. So between stable and unstable, there is a border, is the J omega, or we call it as an imaginary axis that differentiate between the unstable and stable. And the gain at the intersections of the root locus and the imaginary axis will produce critical gain, Kc. Okay. So that's why I put it here, K from 0 to K critical. Okay. So is it stable for A and B? 0 to K critical. Is it stable or unstable? Unstable. So we just put there unstable. Then B, for B, from infinity to K critical. So is it in the zone of what? Stable, unstable? Stable. So you just put stable, ma. Okay. Then we move to the second one, which is K critical to K towards infinity for A. For A. Critical to infinity. So it's a stable. And then for B, from K critical to infinity, unstable. Okay. And BIP, BIP. Ni, mana ni? What is BIP? So what is the BIP for A? Roughly. English lah. We have Arab student. Huh? 2.5 lah. Lebih kurang. Positive 2.5 B. So if no, what is the suitable answer? Not available. And A, not available. One Muhammad. BIP for A. Not available. BIP for B. $2.5. Okay. Pan marker. Majority cannot answer. VIP okay. Stability, no, they don't understand. Due to online. When I say everybody is eating, sleeping, so they cannot catch up during online. So I no doubt there is student are focused, but majority not focused. And as a proof, they cannot describe this. This is a theoretical. Okay. Right. The second one is the quiet please. Plot is not given. So how are we going to plot here? First, you have to find the roots of this. See3143. What is the roots? Where are you? Oh, okay. Okay, so you plot lah. Real axis, imaginary axis. Then use your red pen. Okay, that is the complex conjugate poles that See3143 described just now. -1, J4, minus J4. What else? This one. Open loop poles, -1 plus minus J4. Open loop zeros. Natural? Huh? Positive one. Positive one over here. Okay. So what is the shape? What is the shape of the root locus? How many root locus paths? Smile. It's 9. It's 9 root locus path. It's 9 in Arab, in Malay 2, in English 2, in Chinese Betul? Saya tahu mak saya Cina, saya tahu. That's why your lecturer a little bit Japanese plus Korean face. So what is the shape? What is the shape? We start from, sorry? Not really. Not really. So we start from the origin. This is the origin. Then we scan to the left. So we have a complex conjugate poles. So it will go here. It goes here, and it will go here. Infinity. Okay. And of course, there is a, what is this? Wahida. Wahida is 1. Wahid is 1. Wahida, 1 girl. What is the name of that point? Breaking point. Astaghfirullah. For your name. Ahmad Farhan. Breakaway. Okay, is a breakaway point, not break point. Break point have two classifications: break in and break away. Break away occurred between two poles. Break in occurred between two zeros. Ingatlah. Nak lecturer cakap. Siang malam cakap. Nak. Take note. So what is the question actually? Sketch. Oh, find the break-in point, angle of departure, meaning that you have to calculate. So how you calculate? Ini bukan breakaway mah. Sorry. Sorry. No student raise their hand. All are sleeping. Say, Prof, that is wrong. That is a break in. I just test you. I just wrote there BAP. But nobody dare to raise their hand. All are scared. Maybe your lecturer is professor, so they are. You ask lah. Quiet, please. The dominant pole. This is the dominant pole. Dominant. Complex conjugate pole is the dominant pole. Dominant means very high influence towards the system response. Zero is not dominant. This one not dominant. It's like a family lah, queen control. Your husband and wife. Wife is dominant. So the husband just follow lah. You understand? The dominant, because of the dominance, so it turns to the left. Yep. Okay. Right. So how we calculate the break-in point? Mukri, Ahmad Mukri. How you calculate break-in point? Mukri? Yes, Prof. Apa? One plus. Oh, tolong S square. Okay. Then find K. After that, Ahmad Shahin. After that, so dk per ds. So use the concept. Okay, use this concept, then you will get s square minus 2s minus 19 equal to 0. So what is the roots? Chongjuan? Chongjuan. 5 point. Negative 3.47. So we have two answers. Which one that you must select and justify? Hifzul. Hifzul. Which one? Negative 3.47. Why? Because due to Zarif, due to because minus 3.7 located at left half plane. Everybody follow me? One more time. I can't hear you. Louder. You want to be an engineer, you solve the problem and you must justify what is your justification of your actions. You must come up with the justification. That is engineer job. If you don't have justification, you are like a technical assistant, diploma holder. So engineer must more step ahead. Okay, brain. Then angle of departure. Why we have to calculate as angle of departure, not angle of arrival? Why must depart? Why not arrival? Muhammad Said Tauri. Why we must calculate angle of departure? Why not angle of arrival? Wait, please. Yes, because we have a complex conjugate poles, that's why we must calculate angle of departure. But if we have complex conjugate zeros, so we don't have to calculate angle of departure, but we have to calculate angle of arrival. That's the basic concept. Okay. So how are we going to calculate the angle of departure? What is the formula that we use? Yeah. Takut. Chua Leong. Miss Chua? What formula we use? Miss Chua? Miss Chua? Use angle criteria. Thank you. What is angle criteria? Chung. Sini ramai ni Chinese girl sini. Dia apa? Ada pakatan Of zeros minus summation angle of poles equal 180 degrees. Okay. Quiet please. Shh. Theta 1 is zeros. So what is angle of theta 1? You find this one, this angle first. Theta 1. Tahu Chen? Berapa? Chung? Berapa? Huh? 4/2 4 over? This one is 4. Length ni? Until here mah. Tengok, tak tidur, bagus. Yang lain tidur. Berapa? Hah? Ha. 0.5 lah. Theta tu? Ika? Senang sekali. Theta tu. So? Recorded. Recorded. Minus? Okay. Next questions. This one. Based on the Locus, we determine the value again of K if the system operated at critical dam response. Critical dam response. What do you mean by critical dam response? Arif, Farhan. Arif mana? Wait your turn. Bagus tu, semangat tu. Tapi tak kena tempat. Arif. Zeta equal to 1. So where is zeta equal to 1 in this plot? Now listen. Here, zeta equal to 0. Here, under them, 0 to 1. Here, zeta equal to 1. So meaning that at the break-in point, it will happen zeta equal to 1. So what is the break-in point? Atra, what is the break-in point? So to calculate the gain K, we use the gain criteria. Okay, so what is the gain criteria that we use? Ismail. Ahi, Ismail? Okay. Become hazard? 1.9. Okay, check. Insert the S value inside the K. Dapat? Sebelah kiri Liana. UTM Sanjungan Bangsa, baju merah, semangat. Saya pun semangat. Masuk kan nilai? Attendance moving please, attendance. Dah. Siapa belum sign? What is the value? Denson Pau? Denson. .94. Okay, quiet please. Shh. Okay, soalan nombor 2. Question number 2. Omar Amgad. Brother Omar. Ikra. Shh. Shukran jazilan. Okay, Q2. Today class finish at 7 o'clock. Okay, what to do now? First step, berapa? How much? The zeta value. Yuki Wong. You can use graph, you can use overshoot percentage formula, or you can use zeta formula. 3 methods. Shukran, 0.5. And then what is the correspondent angle? How you get that? $60, huh? Can I borrow your protector? Where is the origin? Where is the origin? The graph. Start, eh? So don't choose lecturer as your career. You know, you have to do masters, you have to do PhD. You know PhD? Permanent head damage. See? Okay. So you must know because our test 2 and our final exam is face-to-face mode. So you must buy about 50 cents. Okay. Go to the station. Okay, that one, quiet please. I don't want to use red. Okay, so I use blue, black, blue lah. Okay. And this is the dominant pole. Okay, so what is the definition of dominant pole? Shomik Hussain. Brother Shomik. You from Bangladesh? Kiamunasin. Baluwase. Donobat. I have been to Bangladesh. Okay, I like it. Okay. So the dominant pole is, what is dominant pole? Definition? What is definition of dominant pole? Dominant pole is a pair of poles that have a high influence towards the output response. Okay, please jot down. Okay. So it's all from the graph lah. So if you have a little bit run away, the value deviate or derail a little bit, no worries. But cannot be too big, okay, from the existing schema answers. So what is B? ES formula 4 divided by, so real is 1 point. Okay. What is C? 80%. 80% of the settling time. So how much? Okay. And what is the real part, the new real part? We call it as a sigma D. Kam Haza? Berapa? Sami? Okay. So what is the new imaginary part? Tangent? Berapa? Okay, that's why the new dominant pole Wengjin, new dominant pole. Okay. Then the second part is to calculate the zeros. So to make yourself, you draw it, okay? When you draw, you have a marks, okay? 3.164 plus J 5.48. Test point. And the values of the apa tadi? Open loop pulse tadi? -1, -6, -15. SEU 15. And put your ZC over here. You can put anywhere. You can put here, you can put here, you can put here, you can put here. You can put here, you can put here, you can put here. Anywhere, assumptions. Assumption, assume. So I assume here. Okay. Then you calculate the angle. So PD is quite tough because you have to calculate the angle. PI is straightforward. You just introduce S plus 0.1 over S, khalas, finish. PD, you have to work out. Okay. Okay. So theta Z is, so you calculate minus 180 degrees. Okay. So you will get 19.03. Then tangent. So that's why GPD is equal to S plus 19.0. Okay. Meaning that this one (19.05). And what is the KP value over here? So you have to calculate that K using magnitude criteria. So what is the magnitude criteria? S plus 15, S plus 6, S plus 1 divided by 19. And replace it with the dominant pole, the new dominant pole. Okay. So what is the value? 20. 28.2. Then you have to calculate the TP. Imaginary. And the system is type 1, type 2, type 3, or type R. The system, type 1, type 0, type 2, type 3, or type R. Tak tahu. Patrick. Where's Patrick? Type what? Type 3. Wow. Ini ajaran sesat. Si Micin. Type 0, type 1, type 2, type R. Why? Because this one is s power of 0. S power of 0 equal to s power of 0 equal to 1. So type 0. Okay. System is type 0 due to no pole at the origin. So use KP. KP is limit s to 0. Limit s to 0. Berapa? Tau Chen. Berapa? .14. Okay. Then lastly, draw. So what is the shape? What is the shape? Ivan. Mana Ivan? Awak. Saya Prof. Ivan, what is the shape of the output? Okay, sketch lah, freehand draw. So the error is, the peak time is berapa? Ni. And the settling time is berapa? Settling time berapa? Huh? 1 point? No. Alas. Yes, Sami. Yes, can. The difference between the red and the blue line is the error. 0.15. Huh? Can be at the top, can be at the... No, it's below. Below there. I'm scared actually. I'm very scared because I'm 56 years old. So, very high possibility. Right, please. Any questions? Any questions? Any question, guy?